Hello everyone and good evening. This is Cody, your dear loved engineer. Welcome back here for my Python tutorials. Now today I want to show you something really special, which I'm using a lot these days, since it's a very cheap and fast technique in order to generate a design of experiment study with simulation files. And yeah, let's directly get started. Maybe let's start off with some theory. So what we want to do is, let's say we have a few variables in our simulation file. Oh yeah, that's awesome drawing here, like very straight lines. Okay, so we have two variables here. Let's call them just x1 and x2. And what we want to do is we want to create some design window here in this design space, okay? And what we want to do is generate a lot of variations of these two design variables. This could, for example, be some length. Oh yeah, that's an L, not an E. Or here's some design angle. I don't know. You could think of any variable in your simulation model. Okay. And you wanna, in this design space, you want to have here this design square. And what we want to do is we want to create many designs here. And what we want to do is we want to scatter them. Okay, so we want to create some design variations. And note that you can now do this with a random, for example, a random function. You just put on this square and use a random function. But we all know that we want to scatter as good as possible throughout this design space, and everyone knows how to do this, hopefully, and if not, he knows in a second. You usually use a Latin hypercube design, which does nothing else than separating this space with very awesome lines. And the trick is that you allow per row and per column only one cross. And if you combine this with some optimization techniques, oh yeah, that's not a good one. I'm so bad in this. Every time I try to make an example for a Latin hypercube design, I absolutely screw up all the time. It's always the same. Yeah, what you want to do is you want to get only one cross per line and per row. Okay, so this is the goal, and with some permutation techniques you can scatter it a lot, because what you can also think of is, if you do it wrong manually, you put one here, here, here. Yeah, I didn't make the design right, I know. And here one, and you see you have per row and per column only one, and this would be really bad, because we wouldn't cover this really wide space here. And you want to scatter it better, like with the axis. Okay, so this is what we're gonna do. And when you have drawn these length or whatever, you want to transfer them into a simulation model, and so you can just run them. And this is a very, usually you use something like lsopt or some preprocessor and stuff like this. But yeah, I want to show you how to do it with Python. You don't need any preprocessor, you don't need anything special at all, no software. All you need is your Python environment. Okay, so then let's get started directly. So I have some files prepared here. Okay, so this is in my folder here, and if you watch in this file, it's a key file, an input file for LSDyna, and what you can see is, yeah, it's a template. I designed it like a template. So you put on these curved brackets, whatever. And write inside some name for this variable. On the left is the naming from LSDyna. R means a real variable, and then comes the name. I really don't like this format. I have to emphasize this. But yeah, nonetheless, we can work with it. It doesn't really matter, but just for the note that this is really strange that you put an R here and there is no space in between, and then you put the name here. Okay, I could use some space here, but yeah, it's just strange. Okay, let's keep it that way. Now, first of all, let's get into Python. Yay! Most people of you will not have, when we write at it, will have PyDOE installed. So just call your Python -m pip. So you call the right pip module when you have multiple distributions, and then just call install PyDOE, and it should download it directly from PyPy and install it. Yeah, as you can see, it's already installed, so I don't need it to install it. Now, when you have it, you can do from PyDOE import LHS, which is Latin Hypercube Design. Oh, that's what is a really difficult one. And yeah, now we want to create the design matrix. Okay, so yeah, let's put it. Yeah, let's make it this way. Say we have 2 variables, and yeah, how many samples? Maybe 4, 10. I don't know. 10 variables is fine. And yeah, what we do now is in order to get the design matrix, you call this LHS function, and for the first argument you put in the variable number. For the second one, you put in the sample count, and yeah, as third, there is a criterion how to optimize the design. I usually use correlation, and that should already work. And let's execute it. And this is everything. The design matrix is made up. I must note though here that the design matrix you have now, you already recognize that there are no bounds to the variables. Okay, so which means that yeah, I didn't give it any lower or upper limits. You would have to adapt it because the design, the way it is right now, let me just get the right color. Here we are. It's just between 0 and 1. Okay, but it really doesn't matter because yeah, you could just simply scale it up into any range which you would like to use. Now let's continue this. So we have here this file. Yeah, that's fine. We have here, and here we have the designs. Maybe plot this. Okay. Yeah, Matplotlib always takes a while. It's pretty huge. So let's create a scatter plot. Let's just take the first and the second variable, and that should already, yay! There's nothing inside. Really good. I like it. Oh man, what did I do wrong? Ah, I found it. Actually, this is something I sometimes tend to forget. You have to input core, and then it's working, as you can see. No, it's not empty anymore. Okay, let's continue. We have this design matrix, and like before, somewhere in the past future, we can simply show it. Yay! And what you get is you get this design space, and as you can see, this is the one bound here, the one bound here, and I tried to optimize already this design. What you can do if you want to have a better scatter, because you see it's much more dense here than in this space, you can enforce this by doing here, hopefully I don't screw up again, I think it was iteration, let me just look it up so I don't screw this one up again too, which is really embarrassing because a lot of people look at me, yet iterations equals 10. Okay, so an S was missing. Now you have this design matrix, And let's just say, okay, this is the first step. Okay, so this way you can create a Latin hypercube design, and you already see I just need a few lines. Okay, so it's really nothing at all. And usually you use very complicated tools for something like this, just creating a Latin hypercube design. And I really don't understand it, why many people use so many sophisticated softwares. I must mention though that PyDOE, I think it is not developed anymore. There is another good project. I will link it in the above the comments section. Another LHS project which was done, I think, 1 or 2 years ago at a university nearby, and yeah, the guy did a great work and implemented a lot of stuff there. So look it up. Now this was the first part. So we have the design variables here. I will just yeah, reset here because this is the first section, and the second task is like I said, we have this template file here in this folder, and remember that we have set it up this way that we do this brackets here and give it names here, and this is for Python formatting. I will show you in a second how this is working. Now let's say now we have the values for every file with this PyDOE, and we want to change this here in every simulation file to some value. Okay, so we want to use this vector we had before, and yeah, just put it in here. Now this can easily be done indeed by switching some stuff. Now the first thing we want to do, there's my keyboard, it doesn't want to work anymore, that's not good at all. So we want to open the file, okay, and please use the with statements, not the open, because it's much more safe for everyone who doesn't know how to open a file. Just Google it, and yeah. And we open this one as fin, which is file in. Yay, very complicated naming. If anyone here has not read clean code, okay, so he should really read it, because it really gives you a lot of recommendations how to write your code, and I have read more than enough bad code, and unfortunately also very badly documented. Okay, everyone was dirty in the beginning, me too, but yeah, that's the way it is, you know. There are dirty times for everyone. They just get more rare when you get older. Now so we opened the file one as fin, the template, and we opened another one which you cannot see now here because it's not written yet. And what we just want to do is we just read in the whole file here to strings. Okay, so lines is just one string which contains all the data, all the text data. And what we just want to do is we use format, and yeah, now we can specify, or have to specify, the names here. Let's just call it var1. We want to set it to 1. Let's say we do var2 to 2 and var3 to 3. Okay, and then comes the really large magic. We do an f_out.write and just put in, oh, mistake, warning. We have to override lines, otherwise it won't work. Because this formatting, you have to assign it new. Okay, so this does not really matter because we can still do it. Okay, now we input here lines, and yeah, that's it. This print here comes from this statement because I formatted it, and it is just printed because, you know, there's nothing on the other side. So let's just watch the second file here, and as you can see, okay, I just replaced this values here with the values here, and everything is fine. And this is really comfortable because with PyDOE I usually create the values, and then I set them here with this very comfortable function. Now there is a trick, okay? So because usually what you don't want to do is when you change your variables for another file, you don't want to write this again and adapt all the arguments, because there could be like a 100 here, okay? I have 30, 50, 60, 70, I don't know. I use many variables. And there's a trick for doing this. You just create a dictionary, okay? And then you do give in the name and then the value. So you just, the key must be a string, of course. And var, yeah, always get the quotes. Var 3 becomes 3, okay? And yeah, I was talking about clean code. I should correct my names, because a clean code is all about reasonable names. Okay, so let's do the stuff from above. Open the two files, and yeah, here it is. Read it, okay? And let's just say format. And now comes one of the nicest things ever developed in this whole programming language. You take this dictionary here, and we want to unwrap it here, you know, because there's already the same information like here, but you must kind of expand it, let's say it that way. So what you do it with, for dictionaries, with ***, and then my_vars, okay? And thereafter, of course, we have to write it again, and hopefully it should have worked. Woo, where is the input file? Yay! And as you can see, it's working. So when you have 30 variables or whatever, just do it as I did. Just create a dictionary with your variable names and the values for every sample, and format them with this format function, and use this ** before the before this dictionary. Okay, and that's it all. This is the way I usually set up fast DOEs. I'm much faster with this if I don't know, try other tools or whatever. It's very uncomplicated, and you can really write a few functions, simplifying this whole process. And yeah, it's really fast. I think every engineer should be able to do something like this, because you don't need sophisticated tools for every simple task you do in your everyday life. I at least don't need it to do it. Okay, so far, thank you very much, and see you next time.